With the speed at which our planet's population is growing, it should come as no surprise that our Earth's non-renewable natural resources will become more and more scarce. The availability of our natural resources is dwindling, and our use of fossil fuels is causing a great deal of damage to our environment. But it's not just oil. The majority of light bulbs use another type of fossil fuel, coal. Indeed, the light bulb has come a long way since its creation, from the incandescent to compact fluorescent, all the way to the newest type of bulb, the LED. We've come a long way in this seemingly minor area, but take this into consideration. Artist Leo Villarreal installed 25,000 LED nodes on the western span of the San Francisco-Oakland Bay Bridge to celebrate the bridge's 75th anniversary in 2011. Thanks to LED efficiency, the display needs only about $30 of electricity to power it for an entire night. While we have made some tremendous leaps and strides in our energy efficiency with everyday items that industrialized nations use, we still have a very serious issue to contend with. In the United States, 39% of the electricity produced is derived from coal. In China, about 55% of the total coal consumed was burned directly by power plants. We extract coal from the earth through mining, mines like these strip mines shown here. Strip mining can be economically efficient, but it obliterates natural communities over large areas. Strip mining also pollutes waterways through the process of acid mine drainage, which occurs when sulfide minerals in newly exposed rock surfaces react with oxygen and rainwater to produce sulfuric acid. While this process occurs naturally, strip mining greatly accelerates the process. Acid mine drainage can enter our waterways and harm fish and other aquatic organisms, and it can even end up in our drinking water. Once the coal is mined, it's taken to a power plant where it is used as a fuel source. When coal is combusted, it releases volatile, toxic trace elements such as mercury, arsenic, and selenium. While the industry has made huge reductions in these emissions, these pollutants and others are still released into the environment with the combustion of coal. So, we know that we need to dramatically reduce our use of fossil fuels. So what are the options? The definition of renewable energy, as defined by dictionary.com, is any naturally occurring, theoretically inexhaustible source of energy as biomass, solar, wind, tidal, wave, and hydroelectric power that is not derived from fossil or nuclear fuel. In the United States, new investments in wind plants averaged $13 billion a year between 2008 and 2013. Most of this investment is due to the Production Tax Credit, or PTC. In this graph from the United States Department of Energy, you can see that the Production Tax Credit was extended in 2010. The result was an additional 20 gigawatts of wind power added to the grid in 2011 and 2012. Wind creates 61 gigawatts of electricity, and it now fulfills 4.5% of our nation's electrical needs. Wind energy certainly isn't the only type of renewable energy. By many measures, the solar energy industry has been one of the fastest growing industries in the United States over the last 5 years. Concentrating solar power has been proven and is in use today. At the end of 2013, the United States had 13 gigawatts of installed solar power, which is enough to power 2 million average American homes. The two types used today for large-scale energy production are parabolic trough and the power tower. In a parabolic system, the mirrors are shaped in a U and concentrate the sun's rays onto a receiver pipe. The pipes are filled with a specialized heat transfer fluid. The heat generated creates steam that drives a turbine that drives a generator. The heat generated is so intense that the Solana power plant can have up to 6 hours of energy storage. In a power tower, water is pumped up to a tower that has thousands of mirrors known as heliostats reflecting the sun's rays at it, heating it to 1000 degrees. The hot steam then powers the turbine. Power towers can use molten salt so that it can retain its heat, giving it the ability to create electricity without the sun for hours. Wind energy and solar energy are certainly appealing to any renewable energy advocate. Indeed, it does sound like they could be the answer. However, they do have their drawbacks. For wind farms, it seems the biggest impact on birds is the fact that they leave the area when wind turbines go up. The effect on bats is much greater and must be taken into consideration as a keystone species. Concentrating solar power's biggest impact seems to be that they kill hundreds of insects per hour and a few birds per year. Concentrated solar power's impact will continue to be studied. The two big issues that wind power and solar power face are the costs and something that needs to be put in perspective to be fully understood. A wind farm large enough to power 500,000 homes at Western standards, it needs to be 119 square kilometers. This is the city of Oshkosh, Wisconsin. Its population is currently 66,778. In order to power this small city with wind turbines, you would need a land mass of 8.6 square miles. The green area shown here shows just how big the area would need to be in order to power Oshkosh with wind turbines. In order to power New York City with wind, you need 765 square miles of wind turbines. This green area completely covers Lake Winnebago and stretches from Neenah, Wisconsin, all the way down to the northern part of Milwaukee. And here's the land area needed to power Oshkosh with concentrating solar power. As you can see, the area is quite a bit smaller. In fact, it's over 5 square miles smaller. And here's what it would look like to power New York City with concentrating solar power. This area is 352 square miles smaller. Now what if I told you that there was a source of power that could power all of Oshkosh, Wisconsin on 57,695 square feet and power New York City on just 0.26 square miles? It is understandable, but unfortunate, that at the very mention of the word nuclear, images of war and destruction are the first images and thoughts that come to so many people's minds. The atomic bomb will forever be a part of human existence. Chernobyl, 3 Mile Island, and the latest nuclear accident at Fukushima are all very real consequences of nuclear power gone wrong. But nuclear energy isn't all bad. Chernobyl and 3 Mile Island are both attributed to human error. And for Fukushima's accident, the Japanese investigation highlighted shortcomings in the actions taken by the federal government, Japanese nuclear authorities, and TEPCO with respect to risk analysis, design standards, and oversight by the operator. New designs in nuclear reactors, such as the Small Modular Reactor, or SMR, offer many advantages and safety features not included in the reactor at Fukushima. SMRs require less on-site preparation, significantly reducing costs. They're only 1/3 the size of typical reactors, which makes them ideal for areas with little or limited space, and they are flexible. As energy demand rises, additional SMRs can be added to meet the electrical needs. They can be built underground, increasing security, and they are incredibly safe. Today's nuclear reactors still require the mining of uranium. Other issues to consider include nuclear waste and its indefinite storage, nuclear waste transportation and the security of, and nuclear facility security against terrorism are all big issues that need to be addressed with nuclear power. And we will never be able to completely remove the possibility of a meltdown. So, we've talked about the environmental impacts of these energy production methods in limited fashion. The total carbon footprint is more in depth and requires talking about things like steel production and transportation of materials to the building site. So the one area left to go over is the cost of each. According to Mike Conley and Tim Maloney, it would cost over $29 trillion to generate America's baseload electric power with a 50-50 mix of wind and solar farms on parcels of land totaling the area of Indiana. Or we could do it for less than $3 trillion with AP1000 light water reactors on parcels totaling a few square miles. Each method of energy production has its consequences. They all need more research and development to become the one answer for all. For now, when I see a wind turbine, I see progress. When I think about a nuclear reactor, I think about the possibilities. Whether we go with renewable, nuclear, or a combination of both, is a decision that needs to be made, and it needs to be made as soon as possible.